everyone. I am Joshua Kalognia, and I welcome you to the online lessons in astronomy. Today's session will be on electromagnetic spectrum. I will give a brief introduction. I will talk about electromagnetic spectrum, electromagnetic waves, electromagnetic radiation from space, and multi-wavelength viewer. We are surrounded by different forms of energy, which we depend on and use every day. Some of these energies cannot be seen, felt, and touched. Examples of some of the devices that give these energies are the mobile phone, laptop, microwave oven, and the television and radio we use every day and everywhere we go. Can you guess what these energies are? These are the electromagnetic radiations. Energy that moves in the form of particles or waves can be termed as radiation. Electromagnetic radiations are waves. These waves spread across a spectrum from long wavelengths to short wavelengths. This spectrum is called electromagnetic spectrum. We have different types of electromagnetic radiations. We have the radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Radio waves are used for communication, such as broadcasting, radio, television, communications, and satellite transmissions. Microwave are widely used in modern technology. For example, wireless networks, point-to-point communication links, microwave radio delay networks, radar, etc. Infrared light is used by electrical heaters, cookers for cooking food, communications, short-range communications like remote controls, etc. Visible light helps us see things. Ultraviolet is used in industrial processes and in medical and dental practices for different purposes, such as creating fluorescent effects, curing inks and resins, and killing bacteria. X-ray is used for checking for fracture, that's broken bones. It's also used in mammograms to look for breast cancer. Gamma rays used to sterilize medical equipment, also used to sterilize food, and used as tracers in medicine. So you can see the wavelength from radio to the gamma. For the radio, you can see a very long wavelength, and as it gets towards the gamma, it reduces. This shows that the radio has longer wavelengths as compared to X-rays and gammas, which have shorter wavelengths. So electromagnetic waves or EM waves are similar to ocean waves. EM waves are produced by the vibration of charged particles. EM waves have electric and magnetic properties and travel through the vacuum of space at a constant speed of light. Can you tell what the speed of light is? So the answer is 3 times 10 to the power 8 meters per second. EM waves have crests and troughs. As you can see here, we have the crest and the trough. So, what do you call the distance between two successive crests and troughs of a wave? So, what do you call this? We call it the wavelength. And this wavelength is measured in meters. So, what do you call the number of crests that pass a given point within 1 second called? So, you can see in this diagram, it's a number of crests that is passing through this within 1 second. So you can see 5 crests, which is measured in hertz. So you can see 5 hertz in this diagram. So this is called the frequency of the wave, and the unit is hertz. So low frequency have long wavelength and low energy, and high frequencies have high energy with short wavelengths. What is one wave or cycle per second called? It's called the hertz. So one wave per cycle is called the hertz, as you can see in the diagram. This figure shows the bands of the electromagnetic spectrum and how well Earth's atmosphere transmits them. The Earth's atmosphere stops most types of electromagnetic radiation from space from reaching Earth's surface. Gamma rays, X-rays, ultraviolet light are blocked by the outer atmosphere. They are best observed from space. Visible light, observable from Earth with some atmospheric distortion. Infrared is absorbed by the atmospheric gases. It's best observed from space. Radio waves observable from the Earth. So you can see in the diagram, the gamma rays have shorter waves, so they are not able to reach the Earth's surface. But for radio waves, they're able to reach. So we can see a radio telescope being placed here on the Earth surface because of the longer waves of the radio waves. So these are different telescopes that can see or detect different types of light. So the Chandra usually detects X-rays. The Hubble Space Telescope, visible or UV. The James Webb Space Telescope is the infrared. Now the Stratospheric Observatory for Infrared Astronomy. This is usually placed in an aeroplane and flown above the Earth's surface for observations. Now the Ghana Radio Astronomy Observatory Telescope, which is a 32-meter dish, and it operates in the radio range. And we have the Southern African Large Telescope SALT, which is optical, which is 11 meter. We have the FAST, which is a radio, which is a 500-meter wide telescope, found in the southwest China. We have the GMT, which is optical, which has 8.4 meter diameter primary segments. So for the multi-wavelength viewer, when you go to this link, it takes you to a site where you can view, example, the galaxy. If you want to view it in the gamma ray range, you can see the change in the color. You can also, if you want to view it in the X-ray, this is how it will look like. If you want to view in the ultraviolet, this is how it looks like. The optical, the same, so changes. It has its own view. Infrared will look this way, and the radio also give you this. So let's take another source. So let's say M1. So M1, if you view it That's a crab nebula. If you view it in the gamma ray range, this is what you see. View it in the X-ray, that's what you're gonna get. The ultraviolet, optical, the infrared, and the radio. So this, we come to the end of this session of electromagnetic spectrum. Thank you for watching. Watch out for the next lesson.